A planet with two suns is real. NASA confirmed it. Scientists bound particles of light together. They compared it to lightsabers. And a machine from Luke Skywalker's farm is running in the Arizona desert right now. You grew up being told Star Wars was fantasy. Impossible. Every bit of it. But here is the strange part. For 50 years, real science has been quietly catching up to that galaxy far, far away. Piece by piece, paper by paper. Some of it is confirmed, some is contested. And one piece of Star Wars is so impossible that the reason why is better than the movie. By the end of this, you will know exactly where the fiction stops and reality begins. Start with the most famous shot in the saga. Luke, standing on Tatooine, watching two suns set. For decades, astronomers doubted planets could survive around two stars. The gravity should tear their orbits apart. Then, on September 15, 2011, NASA made an announcement. Kepler 16b, the first confirmed planet orbiting two stars, a real Tatooine. The discovery was led by Lawrence Doyle of the SETI Institute and published in the journal Science. NASA's Kepler Space Telescope caught the planet crossing its stars. Kepler 16b orbits its two suns every 229 days. Its two stars circle each other every 41 days. If you could stand there, you would cast two shadows. Kepler 16b is a cold gas giant, roughly the size of Saturn. There is no surface to stand on, no moisture farm, but the count keeps growing. Astronomers have now confirmed 18 of these two-sun worlds. And in December 2025, a team at the University of New South Wales reported 27 new candidates, some up to 10 times the mass of Jupiter. Double sunsets are not rare. They are a feature of our galaxy. And Tatooine's desert? Also plausible. A 2011 study in the journal Astrobiology by Yutaka Abe of the University of Tokyo and Kevin Zonley of NASA Ames found that dry land planets have a habitable zone 3 times wider than water worlds like Earth. Desert planets may be among the most common habitable worlds out there. Okay, two suns, real. Now the weapon every kid has swung a broomstick pretending to hold, the lightsaber. In 2013, scientists at Harvard and MIT made photons, particles of light, bind together. Light is not supposed to do that. Two flashlight beams pass straight through each other, always. But a team led by Mikhail Lukin at Harvard and Vladan Vuletic at MIT fired single photons through a cloud of rubidium atoms cooled to near absolute zero. The photons came out stuck together, behaving as if they had mass. The results were published in Nature, and Lukin himself said it. It is not an inapt analogy to compare this to lightsabers. The photons push and deflect each other, like in the movies. In 2018, they went further, binding 3 photons at once, published in Science. So can we build one? No. A real blade would have to be plasma, held in shape by a magnetic field. Fusion physicist Federico Felici of EPFL in Switzerland explained that cutting steel would only take a few thousand degrees. But confining that plasma into a fixed blade is essentially building a fusion reactor in your fist. And plasma physicist David Schaffner of Bryn Mawr College points out the saddest fact of all. 2 plasma blades would not clash. They would pass right through each other. No duel, no sound, nothing. Quick pause. This channel runs on curiosity. If you want more real science hiding inside your favorite stories, hit subscribe. It costs nothing, unlike a Death Star. Okay, back to it. Help me, Obi-Wan Kenobi, the most famous hologram in movie history. In January 2018, Daniel Smalley at Brigham Young University published something in Nature that his own lab nicknamed the Princess Leia Project. A nearly invisible laser traps a single particle and drags it through the air at high speed, while colored lasers paint it with light. Your eye blurs the moving dot into a solid, floating image. Technically not a hologram, a volumetric display. Smalley's own words. To all the heartbroken people who were promised Princess Leia, this really is it. The catch. The images are only a few centimeters tall. For now. In 2018, engineers at the University of Bristol, led by Asir Marzo, built an acoustic tractor beam, a tornado of ultrasound with a silent core that held a 2-centimeter sphere in midair, the largest object ever trapped in a tractor beam. At the Australian National University, physicists moved particles with a hollow laser beam across 20 centimeters, 100 times farther than before. The catch: both need air to work. In the vacuum of space, no tractor beam is pulling in the Millennium Falcon. You cannot move objects with your mind. In 1986, Arthur Ashkin at Bell Labs invented optical tweezers, a focused laser that grabs and moves microscopic objects without touching them. In 2018, it won him the Nobel Prize in Physics. At age 96, and moving things with pure thought? Documented. In 2012, at the University of Pittsburgh, a team led by Jennifer Collinger implanted electrode arrays in the motor cortex of Jan Schurman, a woman paralyzed from the neck down. She moved a robotic arm with her thoughts and fed herself a bite of chocolate. Published in The Lancet. 4 years later, a paralyzed man felt touch through a mind-controlled arm. He fist-bumped President Obama. The force is fiction. This is peer-reviewed. What about jumping to hyperspace? In 1994, physicist Miguel Alcubierre found a real solution to Einstein's equations: a warp bubble. It contracts space in front of a ship and expands it behind, faster than light travel, allowed by general relativity. The catch: it requires exotic, negative energy that may not exist. In 2021, Eric Lentz at the University of Göttingen proposed a version using only positive energy. His design still needs the energy of a tenth of the sun's mass, and other physicists have formally challenged it. You may have read that NASA accidentally made a warp bubble. That claim is contested. A nanoscale structure, not a warp drive. Nobody has built one. And one more heartbreak from the University of Leicester. In 2013, 4 physics students calculated what the Falcon's crew would actually see. Not star streaks. The Doppler shift would smear starlight into invisible X-rays and reveal a single bright disk of light dead ahead. Now the big one. Could anything destroy a planet? The physics is real, and it has a number. To blow apart an Earth-sized planet, you must overcome its gravitational binding energy, about 2 times 10 to the 32nd joules. Roughly every drop of energy the sun outputs in a week. Fired in a single second, the beam would burn with the power of 600,000 suns. In 2012, 34,000 Americans signed a petition asking the White House to build a Death Star. The official response came from Paul Shawcross of the Office of Management and Budget. Construction would cost $850 quadrillion, 13,000 times the world's GDP, in steel alone. And quote, the administration does not support blowing up planets. Why build a battle station with a fundamental flaw that can be exploited by a one-man starship? About those space battles. In space, nobody hears a TIE fighter. Sound needs a medium. Space is a near-perfect vacuum. Every roar and explosion is impossible. But George Lucas knew the feeling he wanted. He cut real World War II dogfight footage into the film as placeholders. Films like The Dam Busters directly inspired the trench run. Sound designer Ben Burt recorded P-51 Mustangs at air races to create the scream of the ships. The most famous space battles ever filmed are Earth battles in disguise. Which brings us to the humblest technology in Star Wars. Luke's family were moisture farmers, pulling water from desert air, the boring job he dreamed of escaping. That machine exists. Omar Yagi, a chemist at UC Berkeley, invented metal organic frameworks, crystalline powders that drink moisture straight from dry air. In 2017, his device harvested water in the Arizona desert, powered by nothing but sunlight. By 2019, it pulled almost a liter of water per kilogram every day in the Mojave. In 2025, Yagi won the Nobel Prize in Chemistry. Think about that. Of everything in Star Wars, the lasers, the droids, the starships, the first technology reality fully delivered was the moisture farm, the one Luke wanted to leave behind. Maybe that is the real lesson. Fiction dreams the impossible. Science answers slowly in its own order. 2 suns, confirmed. Floating images, created. Bound light, real. Warp drives, still on a chalkboard, waiting. A farm boy stared at a double sunset and dreamed of leaving. Somewhere out there, on a world with two shadows, the sunset is real, whether anyone is watching or not. The galaxy far, far away was never that far. It is arriving, one paper at a time. If you enjoyed this, you will love finding out why Star Wars itself is a retelling of the oldest story humans have ever told. Go watch that video next. I will see you there.